this. So we're going to get started first of all by identifying what the calculation is to solve work. So when we are looking at how much work is actually being done by something, we are using the formula work equals force times distance. Now, in order for that to actually work, we need to have a couple of things in place to calculate what work actually is. So if you take a look here, I've drawn a box. And right now there is no work being done to that box because there is no force being applied to it, and there is no distance that that box is traveling. So if we decided that we were going to lift this box up a certain distance, the work would be the actual lifting of the box. We are applying a force and that box is actually traveling. Now, when we are just holding the box in a stationary manner, there is actually no work being done because while we still are applying a force to it, there is no distance that that box is now moving. So the only time work can be calculated is if we have both of those criteria being met. So with that being said, let's take a look at this. If we were going to lift this box up, let's say we were going to lift this box up from the ground up to a distance of 1.5 meters. Now that's important to note. When figuring out the work equals force times distance, distance is always measured per meter. So if you have centimeters or millimeters, you will have to do a conversion in order to get it into meters. So if we were lifting this box up a distance of, let's say 1.5 meters, and it was a 50 newtons, let's say it took 50 newtons to lift this box up. If we take a look at our calculation, we've got the criteria in order to solve how much work is being done. We've got a force, 50 newtons, so the force is 50 newtons, and we are multiplying it by a distance of 1.5 meters times 1.5. So if we were just to calculate that out, we would know that 50 times 1.5 gives us 75 Newton meters, or in science, there is another unit of measurement that means the same as Newton meters, and that is something called joules. So we would go 75 Newton meters or 75 J, and J stands for joules. Now I mentioned earlier in the video that if we had this box and let's say we were changing the distance that it was traveling. Let's say instead of it being 1.5 meters, so here's the same box, and let's say it's 50 newtons to lift it, but we're only traveling half the distance. Let's say we are only traveling 75 centimeters. In order for us to change that into meters, we have to run a conversion on it. We know that there are 100 centimeters inside of a meter, so this is technically 3/4 of a meter. So that's going to change our formula a little bit. So we are going to be work equals still force times distance. Work is then going to be equal to force, which is 50 newtons, times 0.75. And if we do that calculation, if we run that calculation, we're simply looking at work being equivalent to 37.5 joules. And how do we know that that worked? Well, if we take a look at this number, 37.5, it is exactly half of what our calculation was up here, 37.5, showing that even though we had centimeters and had to do a conversion, the formula is still going to work. Now, one final thing before we go. Sometimes you might end up with the calculation for work already, and it may give you a distance, or it may give you a force. And much like any other mathematical calculation, if you have two of the numbers, you can simply flip this formula in order to make things work. So, for instance, if we were trying to find the amount of force, for instance, that was going to be applied to an object, and it gave us the value of work and it gave us the value of distance, we can work backwards in order to find out how much force is being applied. So I'll use the same numbers here just to kind of keep things similar. So in this case, instead of work being equals to force times distance, maybe we're trying to look for force, and force is going to be equal to work divided by distance if we have that. And so let's say that work was 75. Force is going to be equal to 75 joules divided by the distance. So let's say that this distance was 1.5. If we take 75 and we divide it by 1.5, then the amount of force being applied was 50 newtons. And we know that because all we did was transfer some of these numbers around, and we already knew the answer over here, so it made it easy for us to determine what the answer was over here. And the same thing would happen if we were looking for work. If we were looking for distance rather, we could simply take work and divide it by force in order to determine distance. So that is the scientific calculation, and we'll just quickly recap here what we've talked about. There was some brand new terminology that you may not be aware of, one of which being joules, which is the unit of measurement for the amount of work being done. We looked at the formula for work. Work is equal to force times distance. We also looked at how we can manipulate that formula in order to determine a missing component. So for instance, if we were looking for force, then force would be equivalent to work divided by distance. Or if we were looking for distance, distance would be the equivalent of work divided by force in order to determine that. So there are a bunch of calculations on here. If you need to rewatch the video, by all means, please do so. If you have any comments, if you have any questions, by all means, leave them down below and I will get back to them. By all means, please subscribe and share this video as you like. Thanks very much for tuning in today. Have a great day.